In this video, we're going to have a look at some more examples where the distance formula is used in calculations. In the previous video, we saw that the distance formula can be used to determine the distance between 2 points or the length of a line segment. All you need are the coordinates of those 2 points. Example 1. Calculate the possible values of k if the distance between A and B is square root 53 units and A is 1 minus 2 and B k5. So this time, instead of receiving 2 complete coordinates and calculating the distance between the 2 points is given, but one of the coordinates is not complete. We need the x value for point B. So we know that point A is the coordinate 1 minus 2, but for B, all we know is that the y value is 5, so it lies somewhere on the line y is equal to 5. We were also given that the distance between the 2 points is the square root of 53, which is 7,28. So now we can move the point until we find this specific value, and here it is at 3. If we keep moving it, we'll get to the shortest distance between the two, and then the distance will increase again, giving us another option for 7.28. But how can we use algebra to determine these 2 points instead of drawing an accurate sketch? To do this, we're going to make use of our distance formula and substitute all the given information. The distance d was given as square root 53, and on the right we substitute our coordinates starting with x2, which in our case is k, minus x1 of 1. Our y2 is 5, and then we subtract the a values y of minus 2. Next, we can go and square both sides of the equation. This means that the outside squares and the square root will cancel. Remember that the squares inside the square root cannot cancel because we still have more than one term. So on the left, we are now left only with the 53, and on the right, we are left with the 2 bracket squares. So our first bracket is k minus 1 squared, and then we add to that 5 plus 2's square, which is 49. And now we need to solve k, and even though there's more than one way to do it, I'm only going to show one method. Firstly, I'm going to multiply out the bracket squared to get k squared minus 2k plus 1, and then we still have the 49, and then I'm going to subtract 53 on both sides so that we can have equal to 0. And on the right, we then have a trinomial of k squared minus 2k minus 3. Now we have a quadratic equation, which means we should be able to get 2 answers, and we'll get them by factorizing the trinomial. Once you've factorized, either the first bracket or the second bracket can now be equal to 0. This means that k can either be equal to 3 or it can be equal to minus 1. And here our algebraic calculations confirmed what we saw in the sketch. Example 2. The point T is equidistant from the points A and B. Calculate the value of x. The fact that the point is equidistant from the 2 points means that the distances are the same. For analytical geometry, it helps if you always have a rough sketch in mind. Here we were given the coordinates for A and for B, but for point T, we only have the y value, and now we know that point T can be anywhere on the line y is equal to 1. We need to determine where point T should lie so that the distance from A to T will be the same as the distance from B to T. For this, I'm going to take the distance AT and put it equal to the distance of BT. Next, I'm going to use the distance formula on both sides and then substitute all the given information. On the left, we have the x of t that we want to calculate minus that of a, which is minus 2. The y value of t is 1, and we subtract the y value of a. This should be equal to the x value of t minus that of b plus the y value of t minus the y value of b squared. Because both sides of the equation have square roots, we can square both sides to get rid of those square roots. On the left, we now have x plus 2, which should still be squared, and then we have 1 plus 1, which is 2, and squared, that will be 4. On the right, we have the bracket x minus 1 squared, and then we have minus 1, which squared will be plus 1. Next, we have to square the bracket on each side, and after that, we can now get all the x's to one side. So we'll have x squared plus 4x minus x and plus 2x. I'm going to get all the constants to the right, and here we already have 2, and we will subtract 8. Simplifying, the x squares will become 0, and we are left with 6x equal to minus 6, and that means that x is minus 1. So here we had a look at two examples where different algebraic calculations were necessary to solve the variable.